Hello and good day. My name is ChungUn, and today my topic is going to be about TBL, task-based learning, and technology, specifically computer coding and how it can improve creativity and be used in the ESL classroom. Just quickly about technology, I think over the last couple of months, couple of weeks, a lot of us have learned one of two things. Either we're not at the level of technological proficiency that we could be at, or if you are at that level, that it's a really valuable tool to have. Hopefully today we'll think a little bit about if we can go a little bit further. There's going to be a couple of discussion questions which, if you guys are available to talk in the Slack chat later or via email, it'd be really interesting to hear your views. So, just a little bit about me. I'm a high school English teacher. It's an autonomous high school that kind of follows the Korean curriculum, but I actually am able to create my own syllabus. So I teach a wide range: economics, politics, philosophy, and then last year I started branching out into computer coding. I'm specifically interested in TBL. It's what I did my master's dissertation on. And specifically task-based learning in the Korean context. Hopefully today we'll be able to have a little bit of discussion about that. So, here's the first kind of slide for you to look at. Some of you who've never seen any coding before, you might be feeling exactly the same as your ESL learners feel when they see a text of English. You kind of recognise some words and some bits, but it doesn't all make sense. There's a lexis to computer coding, and there's a grammar to computer coding as well, the syntax. And if you feel confused by this, it might help us understand how some of those confused faces look back at us sometimes when we're teaching. Hopefully by the end of today's video, you won't be so confused by it. You might even be motivated by it. So, why teach coding, really, in the ESL classroom? Why are we not focusing on functional language or grammar or things like this? I think I've got a lot of kind of ideas that have popped into my head about it. Coding's becoming more and more valuable in the workplace, but also in university applications, we're finding now in Korea and overseas. The language of coding is English, whether it be on online forums and communities or the actual programs themselves. So I think English is a really good way to step into coding. You can develop your teaching toolkit. There are so many resources out there these days for teachers to develop a basic enough level to be able to introduce it to learners. Coding is really flexible. There are coding programs that work all the way down from kind of cognitive and L2 levels that may be kindergarten, but also all the way up, of course, until university and beyond. These last two are slightly more anecdotal. They're kind of what I've recognised in my class and what I want to try to convey to you today. Okay. What are we going to do? Well, I'll start by introducing this little guy. This is the BBC microbit. You can see it's pretty small. I might put some pictures here and here so you can see it a little bit better. This is what I use. This is the piece of technology that I use to teach coding, and we'll hopefully learn a bit about that. Then we'll learn about how I teach it within a TBL framework. We'll look at some student work. There'll be a little bit of a discussion about, is it right and proper to include this sort of stuff in the language classroom? Is it something that is effective for learners? And then finally I'll give you guys a few what I think are really useful resources, and then we'll wrap up. Okay, so the BBC microbit. It was made by the BBC 2015, there was a real worry within the UK that lots of people were computer literate, but actually programming and coding skills were very, very low. And so one of the goals of the BBC is to be an education provider, much like PBS in the USA or EBS in Korea. And they decided that they would try to improve the coding skills by making a million of these and giving them to every middle school student in the UK. Now, you can't just do that and expect everybody to become coding geniuses. So they also have made a lot of resources for teachers. They've worked with the government, and coding has now become part of the curriculum in most schools. Very similar to what happened in Korea last year. How does it work? Well, simply you type the code, connect it to your computer, send it, and then something magic will happen on this, and we'll see a few examples a little bit later on. Yeah, it's very intuitive, and as most of us are having to grow our technology base at the moment, this is something that is exceptionally easy. Can do a lot of different things. A lot of different things. You can have scrolling text and animation. You can have really cool music and voice simulators, which is really linguistically impressive, and we'll look at that a little bit later on. You can create games, which instantly motivates my students, and also some kind of engineering. We've had robots and cars and stuff like that in the classes that I've done. Yeah, let's have a little think about TBL now. So if we think a little bit now about task-based learning, I'm not going to be too research heavy on this, although I'll be very happy to talk to anybody about it because I'm really interested in it actually. Basically, what happens in a task-based learning class is there's kind of a cycle. There's a pre-task where the teacher will introduce a topic. Maybe they will introduce a possible outcome. They might even give an example. And then we'll get to the task stage. Students will perform a task, usually, ideally, using some of the stuff that was introduced in the pre-task. Then the students will get together and they'll plan a report. Now, with that report, they will actually present it later in the class, either in small groups or to the whole class. Finally, in the post-task section, there's an analysis section where the teacher might lead a Q&A session or a discussion. And then finally, it will finish with some kind of practice of the new kind of either grammar forms or vocabulary or interesting kind of linguistic features that were brought out. That's a basic TBL cycle. That's the one that Willis talked about. That's not to say there aren't people who think it can be done differently. There are, actually. There's a few here. Some of the big differences in TBL come from where we should be focusing on giving explicit instruction, if any explicit instruction should be there whatsoever, and if it should be a focus on form or a focus on meaning. An amazing paper is this one, which Ron Ellis spoke brilliantly about at last year's CoTESOL conference. I'd recommend anybody to read that if you are interested in the current idea of TBL. So how do I use it in my classes? Well, I mainly use coding as a summer school or an after school or winter school kind of thing that I can do with my students. It's really well suited to like a 10-day or 15-day kind of course that you can slowly build skills as you go along. Of course, it can be used in your regular curriculum, and I've done that as well with some classes. an average class would look something like this. There's the pre-task section where I'll teach them a line of code, maybe 2 or 3 lines of code about what each bit of the code does. I'll then give them some kind of basic outcome that I want them to get to. The students will then, either in pairs or by themselves, kind of do the task, get to their own individual outcome, of which there are, we can't use the word infinite, but of which there are a lot. And then, yep, they'll get together, they'll plan a report, and then at the end they'll come and present their code, and then they'll actually show their microbit doing what it was supposed to do. During this phase, I'm kind of facilitating what's going on, helping out with a few little bits here and there on their computers, but I'm trying to stay hands-off. Post-task, we'll think about what it was that they did, how they did it, and then if there's any linguistic features that we want to talk about, whether it be from how they wrote their code, but really how they did their report, or how they explained their code to the other students, that will be done here and here. So what does it do? Well, what does it do really? I mean, students get new chunks of coding language. They do improve their computer literacy. They can change the code about and get to their own outcomes with freedom, with real autonomy actually. They report back to the class, they learn from their peers, and I think one of the things, especially we're thinking about today, is that it's exceptionally creative for them. There's not one path with coding. In the same way there isn't often one path with language. And so the way that they get to their outcome, or the outcome itself, gives them the chance to be creative. So, let's take a look at some student projects, shall we? And again, here's this line of code here, and I'll talk about that in just a second over the video. Thanks. This first example is a simple scroll with lines 5 to 8, the student using when they present their findings to the class. The next is a magic 8 ball, where we can ask it a question and shake it and it gives us an answer. For example, are you going to enjoy this video? Next up is a really simple song. The next example is a limerick that we made where students had to create their own poem.
There was a young man from his head who ran with his hand in a can. One night after dark, he played with Tony's dark, and when he proclaimed, I want when.
I now want to have just a little bit of a discussion about how I feel, and I'd be really interested to hear some of your opinions, either with my email or in the Slack chat, as I said before. So, does coding belong in the language classroom? Is the first one. Is it something that as language teachers we should be providing? Is it something that science teachers, technology teachers should be providing? I think that's a really valuable question. And then secondly, does it actually kind of assist SLA, second language acquisition? If it doesn't, that kind of really comes back to the first question, doesn't it? So with the first question, the difficulties, well, the first difficulty without a shadow of a doubt is actually teacher training. There's not a lot available specifically in Korea, where we're going to be given workshops or stuff like that. It's stuff that we kind of have to do off our own back. It's true for a lot of teachers. Yes, in some countries there is a lot more clear training for this. For us guys, probably not. However, there is a wealth of material out there if you're motivated enough to do it. Materials. It's only £10, $15, but it's still £10 or $15. I was lucky enough to convince my school to buy a fair few of them. Not all of you will be, but schools do have budgets for these, and it's something definitely worth exploring. And of course, access to technology. The last thing we want is pricing students out of English education by not having computers or phones. We shouldn't be putting barriers on the doors to our classroom because students don't have access to that tech. However, Seoul has just managed to provide 50,000 laptop computers to students who are doing their online classes, so the appetite is there from government. It's definitely worth thinking about. The value of coding, well, firstly, coding is really flexible. It can be put and pitched at any level, really. And I've seen it being used by elementary first grade students all the way to university level students as something that they've done. Employability. Here I'm going to talk a little bit about the students first, because so many job applications and especially university applications in the sciences are now asking for proof of any kind of learning that students have done with coding or programming, but also for you. This is something that is just being seen more and more around the world, that this is a real CV builder. And then finally, a little bit about coding languages. It's a language. There's a lexis and a syntax. And the lexis is almost always in English, and the syntax can be challenging and a little bit strange, but it's a language. And like I say, almost every one of them is in English. Now, yes, the science teacher can teach it, but it could definitely be something that becomes collaborative with other teachers as well. But I think having an English teacher working with coding is a really good idea to explain a lot of that lexis. And does it assist SLA? Well, the difficulties here is that there's limited research. Strangely, there's a lot of research, maybe that's a bit of hyperbole, there's some research where programming faculties in universities have actually seen what language faculties are doing and they've taken from them. Most of them have seen it to be successful. So there's research going the other way. Not yet the way I think we need to be researching. There is a high focus on accuracy in coding, and this is a problem. If you write 1,000 lines of code and one T is not capitalized that should be, it might not work. This is demotivational, 100%, and I've seen it. You can switch it round and you can use activities for students to try and find the mistakes, but it is something that we need to think about. And then, of course, computer literacy. Not every student that I teach is really that computer literate. Now, whether or not that's changed after all of the online learning that we're doing now is finished remains to be seen. But again, we don't want to be putting barriers in front of the door of the English classroom. Very quickly, I'm going to talk about a few theories of SLA. If students are motivated by completing tasks, it can assist SLA. If students are being cognitively challenged at the right level by tasks, it can assist SLA. If students are creating meaning-based language exchanges, as they do in TBL and as they do with coding, it can assist SLA. If the outcomes that the students are getting to are using the right type of target language, it can assist SLA. And finally, if students are collaborating with each other, peers inside the classroom, but also on internet forums and kind of globally based coding networks, then it can assist SLA. I think the key point though is here, and it's something that I think we can all think about. So a few things really to take away at the end of this. I hope coding doesn't seem mysterious. You've seen some of the lines of code the students have written and you've seen what it does. Coding can be motivational. Coding and TBL are super compatible because they can be broken down into tasks. It can promote creativity amongst your students. Can help grade you, upgrade your toolkit. I think the use of this in summer school or winter school or after school classes from elementary all the way up to university is something that we could all do. So really now, a few key resources. Free Code Camp. It's a great website. Sign up for free and you can learn to code. You even get real certificates from these guys that are industry valued. The BBC do a great one for the micro-bit, and again the British Council do as well. They were at Code TESOL last year in Seoul. There is a lot of support out there for teachers. So for me, that's it. Sorry if I dragged on, apologies. I've just got a few thank yous. Firstly to Code TESOL, and specifically the staff who've organised this conference. It has not, I'm sure, been very easy for them. And they've worked really hard to keep us all having the chance to expand our knowledge and to share ideas. I have to thank my students. Without them, none of this would have even been a dream of mine. It's been so much fun working with them, and now to be able to share with you. Here's my contact. If you guys have got any questions, please feel free. So yeah, thank you very much indeed. Have a great day, and I hope you see some really great stuff.